Hey guys, okay, so sorry I could not be here today. I'm in a meeting, so Mr. Terrazas is going to help you out. He's got this. Hopefully he has passed out the 4.5 extra examples worksheets to you. So what I'm going to do is I kind of feel like this graphing thing is a little bit sketchy. Get it? Sketchy. So I want to do more examples and kind of try to clarify doing this and make it a little easier, and then I'll go back to the two problems that we didn't get to on the assignment. Okay, so for the first question on this assignment, they're giving us the graph of our function. Okay, so basically what we want to be thinking is if we're going to sketch the graph of the first derivative, we're basically analyzing the slope of this. Okay, so the first thing that we might want to do is we might want to figure out where the slope is 0. Okay, so for this particular example, we have a slope of 0 right here at 0. Okay, so we can graph that point and say, okay, there's a slope of 0 right at 0. Okay, so then I'm going to analyze the two sides. Okay, so remember I'm analyzing the slope. Okay, so if I am looking at this left-hand side, I am basically deciding that I have, well, a positive slope. And hopefully what you notice about the positive slope is that the further to the left you go, the steeper it is, and the closer that you get to 0, the less steep it is. Okay, so we've got like this super steep, and then eventually kind of narrows out. So we have positive slope. So if I was analyzing the number for the slope right there, I would say, oh, it's like 10 maybe, or I don't know, something super high. Okay, and the closer I get to 0, this one is getting, you know, like to 1 or something. Okay, so basically I'm going to have a slope that starts positive, and then curves down and eventually gets to 0. Okay. On the right hand side, I'm going to start flat. Okay, so now we have this positive slope again that starts flat and then eventually gets super steep. So this is kind of going to be the same idea here to the right. So it starts flat and goes steep. And maybe I feel like I drew that a little bit steep, but the same idea. Basically, the first derivative should look like a parabola, okay? And without us really knowing the function, we couldn't really analyze exactly how steep those lines are. Okay. Let's try another one. So for example 2, we've got this parabola. The first thing I want to figure out is when is the slope 0? Okay, so I'm looking for a max or min, and in this case, the x value at 0 again is a maximum. Okay, so now if I look at the left side of 0, I have this super steep slope again. Okay, and this one is like eventually kind of getting flatter as I get closer to 0. Okay, so this one is going to kind of do the same thing. I have this super sharp turn. So this one is probably going to be more steep compared to the last one I just did. Okay, so it's a steeper one. You can definitely tell the slope is steeper. And then on the right side of 0, now the slope is going down. Okay, so I have a negative slope. So it starts out kind of flat and then eventually gets super steep. Okay, so this is going to start flat and then very progressively go down. Okay, so it's basically kind of a straight line. You could even go as far as saying this could be a potential linear function. Okay, so there's actually kind of two options on this scenario depending on what the original function was, but it could be an exponential growth or it could be exactly linear, because for example this equation initially could have been like, let's say negative 2x squared, right? So if I was going to derive that, the derivative of that would be negative 4x. Well, another option for this equation is that it could have been negative 2x to the 4th power. It could have been an exponentially bigger equation. So the derivative of that one would be negative 8x cubed. So that one would look parabolic. Okay, so there is more than one option sometimes. Okay, so either that blue or the red slopes would work. Okay, so let's try another one. Okay, so for question number 3, again, we're analyzing the slope. So immediately I want to look for where the slope is 0, which occurs at maximums and minimums. Okay, so to me there looks to be a minimum value at 0, so that's the slope of 0, so I'm going to plot that here at -4, and then also right here at +4. Okay, so we have 0 and 0 there. Okay, so now what I'm going to do is analyze the slope from the left of -4. Okay, so the left of -4 is a negative. Okay, and it looks pretty flat, so it looks like, you know, close to -1 or maybe even less than -1, and then eventually as I get closer to the -4 value, it gets smaller. Okay, so I would say from here it looks like we kind of like level out. It's not a very big slope, and then eventually gets close to 0 here. Let me redraw that. I feel like I kind of went back up. Something like that. Okay. Now if I then analyze the slope in between -4 and +4, okay, so now you can see I have a positive slope. It's going upward. I start kind of flat. The highest slope occurs right here at this point right here, and so we could even kind of test this and say, oh, that looks to me like it's like a slope of 2. Okay, so at the x value of 0, it looks like it hits a slope of 2. Okay, so it kind of looks like it increases, and then you can see that it eventually decreases again, so it goes up, and then the slope gets a little smaller, although still positive, and goes back to 0. Okay, now to the right of 4, I have a negative slope. It goes downward, and it's a pretty slow slope. It's pretty little, so I have a negative slope, and I would again kind of say it's probably a mirror image of that right hand side, so it probably goes out like that. Okay, so there is my first derivative, analyzing that slope. Okay, let's keep going. Let's try another one. Okay, so for number 4, okay, again, I'm looking for where is the slope 0. That's where I start. Okay, I see a minimum at 0, so I'm going to plot that onto my first derivative. Okay, so now I'm analyzing the slope to the left of it. Okay, when I first start out, this slope looks very flat, and it is a negative. Okay, so it's very flat, very negative. Okay, and then probably the steepest slope looks like right here maybe, when the x value is -2. And I would maybe guess that that looks like a slope of -1. So maybe I'd kind of graph that somewhere in there, and then eventually it gets flatter. So this one's going to kind of get close to 0. It looks kind of flatline. And the highest slope was at -2, or the steepest, and then it goes back to 0. Okay. Now if we analyze to the right of 2, okay, you can see again that I start out kind of flat, and then it gets pretty steep quickly. The steepest spot of this line is probably at 2, and then it gets less steep. So at 2, I'd say that looks like a slope of 1-ish. Okay, so I can see that it goes up, and then it gets flatter again. Okay, close to 0. So there is my first derivative function. Kind of an interesting one. Okay. Hopefully I'm not going too fast, and this is helping you at least a little bit. Okay. So these ones were giving us original functions. So the next section here is now working with, here is my first derivative. We're going to go backwards and draw the original function. Okay. So for this, I'm going to use a number line test to help me kind of figure out what this function looks like. Okay. So remember, my first derivative is telling me something about the function, the slope of my original function. Okay, the first thing I notice is that this splits apart. So I do have a critical value. I don't ever have any 0, so it never touches the x-axis. It looks like it does get like infinitely close on both sides, but it never hits 0. What is probably happening at -2? Okay, well, you can see that the derivative kind of goes exponentially high right there. So probably there's a vertical asymptote at this place. Okay, so I'm going to assume that there's a vertical asymptote. Okay, now I'm just kind of looking at, is this a positive slope or is this negative? Does it exist above the x-axis or it exists below? Okay, so you can see on the left side we have positive slope. It starts slow and then gets super high, so I have a positive slope. On the right hand side I also have a positive slope. Okay, so I know that this function goes up and there's a vertical asymptote, and then it also goes up on the other side. So this is my first derivative number line. I'm also going to kind of do the same thing I did previously, and I'm going to think about the second derivative to help me with the concavity, so the curvature of the way this graph would look. Okay, so for this, what I'm thinking about is I'm analyzing the slope of this graph. Okay, do I have a max or a min anywhere? Okay, I do not have a max or a min, but I still have that critical value of that vertical asymptote. So I know something kind of splits this function in half. So analyzing the slope of this goes up on the left of -2, so we have a positive slope. And on the right hand side we have a negative slope. Okay, so we have a happy face to the left and a sad face to the right. Okay, so to go and draw this now, I'm going to start by drawing my vertical asymptote. That's going to help. Okay, and now what I'm thinking about is, remember how I use my hands to make this curvature. Okay, so with your hands, make on the left hand side of 2 we have a happy face. Okay, so which side of your happy face has a positive slope? Okay, hopefully you're drawing like this with your hands. Okay, so this is basically the idea that we're going to draw right here. Okay, so you can see that I have a steep slope and then it's going to get smaller. So I know it does something like this. The thing that I do not know, and this is why it says possible graphs, is how high or how low this function goes. So this side could be 10 units higher or 10 units lower. I don't know how high, but I'm just going to center this right at the y or the x-axis, make it a little easier for me to draw it. Now working on the right side of 2, I have a sad face. Okay, so if you make your hand with the sad face, which one has a positive slope? So hopefully you're looking at the one that goes like this, right? Okay, so now I'm going to draw that side. So this side is going to kind of do the same thing, and so I know that this kind of is this the hourglass function. I'm working with a rational equation because I have a vertical asymptote, so I know that there's this hourglassy look to it. Okay. Okay, let's work with another one. Let's try this one. Okay, so, ooh, I like this. I'm going to erase these so they're kind of out of the way. Alright, so, again, starting with the first derivative, the first thing I want to think about is I am analyzing, or it is analyzing the slope of my original graph. So, I want to start by figuring out when is the slope 0. Okay, so when does this cross the x-axis? So, I see 0 and... boy, that's not a nice number. That looks like at 1.2. Can we just go ahead and we'll just pretend that's a 1 if you guys don't mind, just for simplicity of this idea. Okay, so let's just pretend it crosses right through at 1. Okay, so we have a positive slope to the left of 0. It exists above the x-axis. There's a negative slope, a very small negative slope, and then a super steepy slope later on. Okay, so if I was going to kind of connect this dots, it goes up, it goes down, it goes up. I'm thinking this looks like a John Travolta. Okay, so I know I have this max at x equals 0. I have this min when x is 1. Okay, probably it's a John Travolta. Let's talk about the concavity of it. Okay, so let's use the second derivative, which is going to analyze the concavity of my original function. And to come up with this, I'm thinking about the slope of the first derivative. So to go from first derivative to second derivative, I'm analyzing this slope. Okay, so the first thing I'm looking for is when is the slope 0? That's a critical value. So I would say, again, that's not a nice number. Let's just say that's at 1/2, kind of halfway in between 0 and 1. Okay, so it minimizes at 1/2. Okay, so if we're looking at to the left of 1/2, what kind of slope does this have? It goes down, so it has a negative slope. If we look to the right, it has a positive slope. Okay, so it goes up. So now I'm thinking, okay, if I'm going back to my original function, second derivative tells me about the concavity. So I have a sad face and I have a happy face. Okay, so now does this work with our John Travolta? Okay, so think about this. If I go from negative infinity to 0, negative infinity to 0 would have a negative concavity. So make your hands in a negative sad or a sad face, and it would have a positive slope. So you're going to be drawing this curve first. Okay, so we're going to stop at 0. Now I don't know what the y value is. I have no idea what the y value is. So I'm going to start down here and I'm going to curl, and I just nailed at 1. We're going to call that my max spot. Okay, now from 0 to 1/2, we have a negative slope and a negative concavity. Okay, so again, put your hands in the sad face. Which one has a negative slope? Okay, and hopefully now you're drawing this side. Okay, so we're going to go down. And we're going to go down only until 1/2. So this is going to be a very short, quick trip. You're going to go down. Okay, so it's quickly down. Okay, and then at 1/2 to 1, we have our happy face. Okay, so 1/2 to 1, you got your happy face, and it has a negative slope, so it's going to go back up. Oops, sorry, that I almost drew too much of my happy face there. Happy like that. Okay, so it's going to kind of go curved like so, and remember that I have a minimum value at 1. Okay, so that's going to be a minimum, and then we have a happy face, positive slope. You can see it's going to go upwards. Okay, kind of drew that to the right a little bit, which I guess matches my original a little bit more. So you can see that John Travolta kind of appearing. Okay. Let's do one more. Actually we got a couple more, and these are just really good practice problems. Okay. Number 7, okay, so we're going to analyze what is given to us as our first derivative, okay, so we're looking for where the first derivative is 0, okay, so where does it cross the x-axis? I see it crosses at -4, and it crosses at +4. So to the left of -4, we have a negative slope, so it's negative, it exists below the x-axis. Between 4 and 4, it's above the x-axis, so we have some kind of a positive slope. And then from 4 on, we have a negative slope. Okay, so if I kind of connect this, it's going to go down, up, down. Maybe like a John Travolta, but looking at the original one, I'm thinking not so John Travolta-y. There's probably some little bit more stuff going on. I do know I have a minimum right there at -4, and I have a max at +4. Okay, so remember that. Okay, so now let's use the second derivative to pull out the concavity. This will be helpful. Okay, so second derivative, I'm analyzing the slope of my first derivative. So I'm looking at when is the slope of this 0. So I'm looking for a max or a min. So I see a maximum right here when the x value is 0. So that's 0. Okay, so now looking at the slope of this, is the slope increasing or decreasing on the left of 0? Okay, increasing. And to the right of 0, it's going down, so it's decreasing. Okay, so we have a happy face, and then we have a sad face. Okay, so now thinking about our graph. So we have a minimum at -4, a max at +4. We have a point of inflection, right, at x equals 0. Okay, all right, so let's talk about from -4, or negative infinity to -4. So negative infinity to -4, we have a negative slope and a positive concavity. Okay, so happy face, negative slope, we have this curve. Okay, and I want to kind of match this to what I see right here. Okay, so notice that the slope is very flat. Okay, so probably this is going like almost, like it almost looks constant, you know, at the very end. Okay, so probably this is decreasing. Hold on just a second. Yeah, sorry, decreasing very slowly. Okay, so we got, let's say we're going to start, we'll just use our x-axis to kind of help us. So we'll say it probably is going like this, and then it goes like that. And that's not a good job. Let's say it goes to there. So I know that there's this minimum, and it's a very flat curve. Okay, and then from -4 to 0, we have a happy face and a positive, so then it curves up like this. Okay, so it's going to curve up to 0. Let's go to 0, 0. That seems like a good spot. Now I could technically go up to any y value, right? So a happy face to any y value. That almost looked like, there we go. Okay, and now from 0 to 4, 0 to 4, 0 to 4, I have a sad face with a positive slope. So now I'm going to go, oh, I keep drawing that too far. That curvature. Okay, so I'm just kind of doing that, and I'm just going to kind of mirror-ish what I saw down here. So this one had a min at -3, so I'm going to say this one maybe has a max at 3, and I wouldn't know that for sure, although this looks pretty symmetrical, so I would assume that these maxes and mins are somehow symmetrical, although it would be potentially moved up or down some amount of units. So from 4 to infinity, I have a negative slope, negative concavity, so now we're going back down again. Okay, and notice that this slope right here gets really, really flat. So I know that the slope is negative, it's going down, but it's like really slowly. So it's like so. Okay, and it almost looks like these could potentially have slopes like this. Looks like this does eventually just become a slope of negative, I don't know, whatever that would be, -1/4. So it looks like this probably has some kind of like asymptote right there that makes it keep going almost linearly. Okay, one more. Let's do number 8. Okay. Let's use green. Okay, so let's talk about our first derivative. Okay, so remember that this is analyzing our slope. Okay, so I'm looking for when is the slope 0. So when does this cross the x-axis? And I see it crosses at 0 and it crosses at 2. And the other thing I notice is that it looks like there is a vertical asymptote at 1. So that's going to be a critical value. Okay, and I'm going to say vertical asymptote at 1. So you see how that goes, that slope is so incredibly steep. That's telling me there's a vertical asymptote there. Okay, so on the left of 0, we have a positive slope. Very small positive slope. Okay, and then on the right of 0, this one gets pretty quickly, that's kind of a steeper one, but it is a negative slope. And then on the left of 1, negative slope, also kind of steep. And then to the right of 2, we have this flat positive slope. Okay, so we got this up, down, down, up. So we have a maximum at x equals 0. We have a minimum at x equals 2. Okay, with a vertical asymptote. So hopefully you kind of know what this is looking at like for a second. Let's talk about the concavity of it. Okay, so to figure out its concavity, I'm going to analyze the slope of the first derivative. Okay, so I do not see a max or min on here, so the only critical value I'm going to look at is my vertical asymptote. Okay, so from the left of the vertical asymptote, is it increasing or decreasing? It's going down, so it has a negative concavity. And from the right, it's going up, so it's positive. Okay. So for this one, if we go from negative infinity to 0, remember 0 is going to be some kind of max. We have this sad face. Okay, so we have a sad face that's going up, so it's going to start kind of like this. Okay, but what we have to remember about this is that the slope to me looks almost linear. Like probably there could be this slant asymptote, and it looks like the slant could potentially be at like 1/2. So imagine like there's some kind of slope at 1/2, like and maybe it doesn't go through the origin, but maybe it's up or down, who knows, we don't know that. Okay, so if I draw my upper curve, okay, so I'm going to draw it below it. Okay, and we'll say it goes up, and then it kind of curves to here. Okay, I've got a max at 0. Okay, and then from 0 to 1, I have a sad face with a negative slope, so then it goes down. Okay, and you notice that the slope goes really steep, so remember that vertical asymptote. It's going to go down super fast to that vertical asymptote. Okay, on the right of 1, we have a negative slope, so it's going down, but we have a happy face, a positive concavity, so it's going like this. We have super steep. So we know that if there's a vertical asymptote, this is splitting apart, so it's going to go up here, and I know I'm going to 2, so I'm going to minimize somewhere at 2, so we'll just say that looks like a good minimum spot. And then from 2 to infinity, we have a happy face, and it goes up, so it curls up. I'm going to get this a little closer to my little slant there. There we go. And then it curves up on that slant. Okay, so you can see that slant comes in on both sides. That slope of 1/2 or 1/4 or something like that. So it could be a little flatter than the way I drew it. Just remember that I could potentially take this, all this stuff that I drew, and move it up or down. Okay, I do not know what the y value is, so I could potentially move this like that, and that could be exactly the same graph as this. I do not know. Okay. All right, so just making sure we got this. Okay. For number 9, we're given the second derivative, so we're analyzing the concavity, and we're trying to come up with the original one. Okay, so using concavity, how can we go from that to the original one? I'm not going to draw this, I'm just going to look at the multiple choice options that I have and then figure out which one could possibly work. Okay, so if we're thinking about the concavity of this, okay, I can see that this is splitting apart at 3, and since I don't have it ever hitting 0, I don't ever have a point of inflection. So I probably have vertical asymptote at 3. Okay, and I have a positive concavity to the left of it because it's going upward, it's above the x-axis. And then on the left side it's below the x-axis, so I have a negative concavity. Okay, so I have a happy face and I have a sad face. So which of these functions could this possibly be? Okay, so is this right here a happy face? No, that's a sad face. This linear piece has no concavity, so I know that it can't be B or D because it's linear. That doesn't make sense. There's no concavity for that. So would C make sense? Do I have a happy face to the left of 3 and a sad face to the right of C? That one would work. Okay, so C would be your option for number 9. Okay, let's try number 10. Okay, so for number 10, we have a positive concavity of 1. Okay, so pretty much we have a positive from negative infinity to positive infinity. We got this happy face function. So A, we know it's not A because there's no concavity of a straight line. Ditto on B. Does C look like a happy face? Nope, half of a happy face. So for this one, it would definitely be D. This is the only one that has a happy face. Okay, so, oh, we got one more. Let's do the last one. Okay, so again, ooh, this one has 3 little pieces. Okay, so this one has 2 vertical asymptotes, it looks like, at -1 and maybe +1, somewhere in that area. So we have a happy face, and then this one is below the x-axis, so we have a sad face, and this one is above again. Excuse me. Okay, so again, trying to figure this out. I wish they didn't give us it straight lines, because those have no concavity. Those are easy to eliminate. Would A work for this? Does this piece have a happy face? Yeah. Sad face? Yeah. Happy face? Yeah. So A definitely could work. Notice that B cannot. We have a happy face, and then we have, this one actually has a happy face, sad face. So this one would have a critical number at 0 as well, so it's not that one. Okay. Oh, I do have more on here. Oh, what the heck, let's just finish this off. Okay, so do I have any 0 concavity? It hits 0 at 0, so that's my critical number for this. We have a sad face. It looks like this is a horizontal asymptote, and very hard to see, but it exists below the x-axis, so we have a sad face. And over here we have a happy face. So we have sad face, happy face. Okay, so notice that this right here, the curvature gets really, really flat. Okay, so that these 2 end pieces is basically telling us it's becoming linear the further away we go. Okay, becoming linear the further away we go. Okay, so again, let's cancel out our linear functions that have no curvature. Okay, so for A, is this a sad face? No, this one is kind of opposite of what we want. How about this D? This one is sad face. It does look like it starts to level and become linear, and then this one is kind of a happy face. So, yeah, D. Okay. So, hopefully that did help you a little bit. Maybe clarify things a little bit more. So, let's go back to where we left off yesterday with the assignment. Where did I leave off? There we go. Okay, so we left off of question number 10. Okay, so I did ask you to go to 16, but we're going to do 10 and 11, and then your assignment will be to finish the 4-5 assignment. And, well, 4-6 is not new, it's the review. So, okay, we're going to talk about that at the end of the video because we have a test coming up. Okay, so let's see, we got, they give us the function, the derivative. Okay, so they're giving us the slope of our original. We're going to come up with the second derivative and then the possible graph of f. Okay, so for this one, the first thing that I want to do is kind of analyze our slope. Okay, so our first derivative, we have slopes at, our slope of 0 at -6, 0, and 6. So we have -6, 0, and +6. So, oh, this does say sketch the graph of the derivative. Okay, so, sorry, I'm going to go backwards a tad bit and do that. Okay, so to do the second derivative, I'm looking for when is the slope of this 0. Okay, so I see a max at -4, and I see a min at 0, and I see a max at 4. So those slopes are max, so let's do this. There we go. First derivative, second derivative. So we got -4, 0, 4. There we go. Okay, so then the slope of this, so if we're going from first derivative to second, we're analyzing the slope of this. So it has a positive slope to the left of 4. So it goes up, and then it has a negative slope to 0, so down, then positive slope and whoops, I should go further out, and negative slope, there we go. So this goes up, down, whoops. Oh, so this is analyzing that. Okay, so hold on. So to draw our f of x equation, I know this is going to look like a John Travolta. We're going to cross at 4. 1, 2, 3, 4, negative 4. We're going to cross at 0. We're going to cross at positive 4. Oh, cannot draw symmetrically. That looks pretty good. Okay, so we have a positive slope, so it's going to exist above the x-axis. Okay, and you can kind of say the slope of this gets steep and then kind of goes to 0. Okay, so it gets steep and then kind of curves going to 0, and then has a negative slope and goes down. So we go, probably the steepest part of this is going to be halfway in the middle, right there. So it's going to go down right at about -2 and going to have a max value, and then come back to 0. So it goes back up. Okay, and then on the right of 0, we kind of have a positive slope that starts flat, so it's little, and then kind of halfway in between. It looks like the steepest spot to me is at 2. And then it comes back to 0 after that. So it goes up, and then it comes back down. And then the slope again starts close to 0 and gets steep, so it goes away. Okay, so we come up with this John Travolta. Okay, so now let's go back and analyze what this potential function would look like. Let's use blue. So if I want to draw my first derivative number line, I always think that is the most helpful. Okay, so again, what I'm looking for is when is the slope 0? Okay, so to me, it looks like at -4, or whoops, when is the slope 0? Excuse me, I'm looking at a max. But the slope is 0 at 6, -6. 0, slope of 0, and at 6. There we go. Okay, so this is analyzing the slope. So from the left of -6, the slope is below the x-axis, so we have a negative slope. Between -6 and 0, it is above the x-axis, so we have a positive slope. Between 0 and 6, we also have a positive slope. And from 6 to infinity, we have a negative slope. Okay, so for this one, this will kind of be interesting. We're going to have, it's going to go down, it's going to go up, then up some more, and then down. So what I know from this graph is that we have a, let's go to minimum first. We have a minimum at x equals -6, and we have a maximum at x equals 6. Okay. And then now if we go back to the the second derivative and analyze the concavity of our original graph, we have a happy face, sad face, happy face, sad face. Okay, so let's draw this kind of to the right so we're kind of next to each other. So this will be my original function, my f of x. Okay. Alright, so we go from -infinity to -6. So let's draw our little increment. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so from -infinity to -6, we have a positive concavity and a negative slope. So for my happy face, I have a negative slope, so it's going to start with this curve down here. Okay, so from -infinity to -6, we have this low, and I do know it's a minimum, so I'm going to just start this kind of below somewhere. So it's going to go down. We're going to say that's going to be my minimum spot. Okay, So now I know it's going to go back up. So I have a positive slope with a negative with a positive concavity. So it's going to go up like this. Okay, and we have a point of inflection at -4. We have a point of inflection at 0 and a point of inflection at +4. Okay, so it's going to go up to 4. So I don't know how high that could go, but we have this some kind of happy face till 4. And then from -4 to 0, we have a sad face. So -4 to 0, we have a positive slope. Okay, so sad face with a positive slope is going to be, whoops, like this. Okay, so we're going to kind of curl upward. So it's, I don't know, it's going like that. Okay, and then from 0 to 4, we have a happy face. 0 to 4 with a positive slope. So that's going to be this curve. So it's going to curl. So it's going to curl back up. So keep kind of curling, and I'm going to +4. So I'm going to kind of keep doing that positive curve until I hit 4. And then from 4 to 6, I have a sad face with a positive slope. Sad face with a positive slope. So we're doing this one now. Okay, and remember that I have a max at 6. So it's going to kind of curl up. And since I have a max, it's going to go back down. We have a sad face, and now it's going to curl back down. And this will just keep going downward forever after that. This side is going to go this way, in that direction. So that one is kind of a, whoa, pretty gnarly looking function. Okay. All right, let's try 11. I think this one is a little bit easier. It's less gnarly. Okay, so first let's do the graph of the second derivative. Let's see if I can get this all in here and looking nice. Okay, so let's do this in black. So second derivative. Okay, so for this we're analyzing the slope of this. So basically we have what could potentially be a sharp turn. So we have a negative slope, or a positive slope. No, excuse me, a negative slope, it's going downward, and then a positive. So down. So it's going to go, let's see, like this. And we could potentially have a vertical asymptote here at 0. So it's going to go like that, and then like that. Okay, so both of these have negative slopes. No, sorry, this has a negative slope, and this has a positive slope. So negative slope, positive slope. So you can see that if you're analyzing, the closer you kind of get to, here, let's kind of zoom in on that a little bit. The closer you get to the sharp point, the steeper it gets. Okay, so you can see to the left of 0 it gets steep, and then to the right of 0 it's also steep. So that's why we could potentially have a vertical asymptote. So we'll just assume there's this vertical asymptote in there. Okay, so now let's graph the original function. So to do that, let's start with drawing the number line of our second derivative. Okay, so for the second derivative, we had that critical value of 0. Okay, so for the slope of it was a negative and then positive. So we got a negative, positive slope. Okay, so we have, to go to the original, we're thinking this is sad face, happy face. Okay, if I analyze my slope of the derivative, so the one that's given, again that 0 is going to be, it's a slope of 0 because it looks like it touches that. So that is a slope of 0. And then we have let's see, for first derivative we have positive, so positive and positive. So these are above the x-axis, above the x-axis. So positive, positive. So this one basically is going to go up and then go up some more with leveling out at 0. So we have this point of inflection at x equals 0. Okay. So this one, let's draw this off to this side. So this is my original. Okay, so point of inflection, so to the left of 0 we have a sad face with a positive slope, so it's going to go like this curve. Okay, so we got up, and who knows what the y value is that it goes to. Could be 0, could be -5, could be 10. Okay, to the right of it has a positive concavity and a positive slope, so a happy face with the positive, so it's going to go up. And since we know that the slope is 0, we know that this point of inflection, it's a continuous function, so it goes up from there. So basically we have this John Travolta that exists. Okay, so this could be shifted vertically or not. Okay. Alright, so with that, what you guys need to do is finish this assignment, and then we will start the 4-6 assignment. So tomorrow we'll start 4-6. What I think we're going to do is, since 4-6 will be Friday and Monday, I'm going to give you the test of part 1, the non-calculator portion. So actually it'll be part 2. So I'm going to give you the non-calculator portion for Tuesday. So you'll do that in class. And then what I'm going to do is I'm going to give you the calculator portion as a take-home test to do over the break. Okay, so I do realize I'm not in class, but hopefully everybody is getting this video. We'll talk about it again tomorrow. So if you do have extra time, you can start the 4-6, you know where you're going, but there will be a test, at least a part 1, on Tuesday. Okay, so we'll see you tomorrow.